Hi guys, welcome to 5mantra.com. This is Kalyan, the faculty of aptitude, and today we are going to discuss one different technique of mensuration once again, using which you can solve two different cases with a single shortcut. Okay, once again remaining two different cases of mensuration with a single shortcut. Means it's also useful thing if you utilize properly, right? Let us see. It's also about square and sector combinations, square and semicircle combinations. In both the cases we get the same answer. Let us see the first cases out of them. Okay, just see here. Let us observe this diagram. Look at this, guys. In lot of examinations you might have observed that this kind of diagrams will be given, and you need to find out this flower shaped region or this remaining shaded region in the examinations. This is a very frequent question in lot of CGL and CHSL notification. Not only in that, other than in academics also, below 10 standard, it's a wonderful question. Okay, let us see what it is, and we need to find out here white colored shaded region. What we need to find? First let me specify that. Okay, what is it? We need to find white colored shade. White color shade is our target to find. Once again, showing in the diagram part which is white colored shade, this part, this part, this part, and this part. And that means here total white color shaded region is showing this one. Okay, so here which is showing a flower shaped area. Okay, and we need to find out the flower shaped area and find it out how to design the concept. See here friends, I want to tell you I will analyze this in two models. Two different ways I'll analyze. First one is direct approach, and second one is based upon the previous technique we can solve this. First of all, direct approach we'll see. Okay, but direct approach is a bit more analytical, in which you need to apply your brain a bit more. Okay, let us see what it is. See here. Okay, have a look at this. We have given a square, for which example the side would be some A. Side of the square is A, and we need to find out that flower shaped area. Okay, that flower shaped area represents what? First we have to analyze the figure. So if you want to know, see, is this a semicircle or not? And is this a semicircle or not? Means here inside a square, how many semicircles are inserted? Exactly 4. Why? Because here this is one semicircle, and this is another semicircle, and this is another semicircle, and finally this is also one more semicircle. That means total 4 semicircles are inserted into the square. Then first of all, our clarity that what does this shaded, means white shade part is refers to, means what does it represents. To find out what we have to do, for that I am giving you some diagrammatic analysis for that. Let us have a look at this. See guys, here I'm just for a moment I'm plotting one square. Just see. So it's a square. Okay, let us see. It's a bit more. Okay, now it's a square, and we just want to draw one semicircle. Okay, what it is, let us see here. Try to grasp the concept what I am going to explain here. Here how many semicircles are introduced into the square at the beginning? 2 semicircles or not? Okay, now what the area is remained over there? Tell me. Here this is remaining area or not? Is this a remaining area or not? This is remaining area, and this is remaining area. And I'm telling you initially that if suppose you fill that area only, this area only, if you fill, then it is totally equivalent to square. Now instead of filling that, what we did is Just see. Now how many semicircles we have introduced? 2 semicircles. Now what is the space left inside this one only? No. For an instant, if you think that just you finish this part only, if you fill this part only, means only this part and only this part, then it will total square will be filled. That means that will be equivalent to total square area. But what we did, we entered one more two more semicircles into that. 2 more semicircles in the sense, for example, here see, if you take one more circle here and now when we have drawn 2 more semicircles, then what happened here is, other than not only filling this remaining space, but here these 2 semicircles are overlapping the remaining 2 circles. Is that right or not? Here this semicircle is overlapping these 2 semicircles, and this circle is overlapping these 2 semicircles, and this semicircle is overlapping these 2 semicircles. Why? Because see, I want to tell you here, one thing is happening inside the square. What is going to be happened here? Inside the square, total 4 semicircles are drawn, and each one semicircle is overlapping another 2, and because of that and that overlap region, and this overlap region is only representing, this overlap region is only representing what? This flower shape or what here in this white color part. Is that right or not? Here that overlapped region due to one semicircle on the remaining 2 semicircles is only representing this shaded portion, and in case of our diagram, this white colored part, right? So now why we are getting that overlap? First, we have to think with a common sense. When the overlapping region comes, whenever there is no space inside which is sufficient for 4 semicircles, means here there is no sufficient place inside, there is no sufficient area inside the square, to be occupied by 4 semicircles. That means here 4 semicircles area is more than squares area. Is that right or not? Here this semicircle and this semicircle and this semicircle and this semicircle, 4 semicircles are occupying more area than 1 square. Is that right or not? Then anyways, while finding the from previous problem, we are doing the shaded region or not, we are finding the areas of shaded region. But what we are doing over there, we are subtracting inside figure from outer figure. Is that right or not? But it is one, I'm asking you one question, that is it important to subtract the inner figure from outer figure, or is it important to subtract the area occupying low area from area occupying high area? That means we have to subtract area occupied by high area minus area occupied by lower area. Here high area means more area is occupied by which? Whether the semicircles or square? Semicircles only, no? So here these 4 semicircles are occupying more area than the square. Getting my point or not? Their 4 semicircles are occupying more area than the square. That means here one thing you might have understood. More area minus less area is creating this shade. Is that right or not? What is this shade? Once again I am explaining. Try to get my point. Here this is overlapped region only, no? This is overlapped region only, no? Why the overlap is occurred? Because there is no, area equivalent to that overlapped part, that flower part, is insufficient inside the square. That means here difference of the sum of the areas of 4 semicircles and square represents that. Clear? difference of the areas of four semicircles, okay, and square represents this shade. Clear? But here we have to subtract the square area from four semicircles area. That is the final thing. Okay, and I want to just tell you, if you want to find out the shade region, we have to subtract area of the square from area of four semicircles. If you want to find out the area of the semicircle, what the measurement is required? Here, for finding the area of each semicircle, what is required? Radius or not? So here, as we said, side of this is A. Okay, when side of the square is A, then is it behaves as a diameter of each semicircle or not? So is it a semicircle or not, guys? See here, this is semicircle, and for this is a diameter. So we can say that diameter of each semicircle is equal to side of the square. Diameter of each semicircle is equal to square. That means here diameter is also A. That means radius is half of the diameter. So here radius equal to what? Half the diameter, and that would be your A by 2, right? So here we could find radius of the each semicircle and side of the square also. So what is your next step? We have to subtract the square area from the four semicircles area, because four semicircles area is more than square area. Because of that only we got overlap. Clear? Now let us do it. Now let's do it. Here this is a radius A by 2, and this is A by 2, and this is side A. Clear? So now what we have to find? Area of the shade is equal to area of four semicircles. See guys, I want to tell you one more thing. Sum of the areas of four semicircles, in the sense, when you add two circles it will form, okay, when you add two circles it will definitely form what? A full circle or not? Means four semicircles area is equivalent to two circles area. Better we find two circles area now, because if you attach the two semicircles, each becomes one circle. Like that, four semicircles is equal to what? Two circles. So here two circles area. Okay, two circles area, and that would be how much? Here two circles, no, means 2 times of each circle area. Each circle area will be how much? Pi r. R is how much? A by 2 whole square. That would be 2 pi a square by this 2 square is 4, which would be your, okay, pi a square by, say I write here, pi a square by 2. Clear? So what is the sum of the areas of two circles? Why I took two circles, I'll explain you just once again. Please look at this. Here this is one semicircle, and this is one semicircle, and this is one semicircle, and this is one semicircle, means 4 semicircles. If you attach every 2 semicircle, it becomes one circle. So instead of considering 4 semicircles, I considered them as two full circles. So two full circles area, each area would be pi r square, where r mean radius is half the side of the square. That means pi a by 2 whole square. How many such a circles we took? 2, because 4 semicircles. Okay, 2 full circles. So what is the area of sum of the areas of all? Pi a square by 2. Now let us move on to next. Okay, so now here 2 circles area, and what is square area? Square area would be what? Its side is A. That means its side is A, means its area obviously what? A square. Now if you want to find out the shade area, shade area means, shade means here white shade area, white. In this diagram it is white color, no? Whatever the color is given, that flower shape area. Okay, that flower shaped area is equal to sum of the areas of 4 semicircles minus area of the square. So that would be how much? Pi a square by 2 minus a square. Clear? That is pi a square by 2 minus a square. So how much is that? A square can be taken common. That would be your pi by 2 minus 1 into a square. So this would be your final answer. If you want to make it simplified to final numerical terms, then this would be how much? Pi value would be 22 by 7 or not. Let me simplify here. 22 by 7 into 2 in denominator part minus 1. 2 11s are. Means 11 by 7 minus 1. 11 by 7 minus 1 means how much it is? Okay, 11 by 7 minus 1. See here, 11 by 7 minus 1. If you take LCM, 11 minus 7, 4. 4 by 7. So final answer of this white colored shaded area or flower region area is how much? 4 by 7 a square. This is a conventional method to find out the shaded region, that means flowered region. This. Clear for you guys? So how did we find here? Once again, with a short explanation, I am telling you here what we did. We analyzed that these are 4 semicircles which are inserted in the square. When they are inserted, we are finding something that here each semicircle is overlapping another 2. So when this overlap takes place, when there is no sufficient area in the square, that means 4 semicircles are occupying more area than square. So then the shaded region, or here the white colored region, flower region, represents the difference of the areas of 4 semicircles to square. So 4 semicircles area, if you want to find out, the radius is required. So radius would be how much? Half the side. That is a by 2. So a by 2. Okay, a by 2 is the radius. You substituted and we got how much? Pi a square by 4. And here area of 4 semicircles will be equal to area of 2 full circles. So 2 into pi a square by 4. So that would be pi a square by 2. Right? And we subtracted a square from pi a square by 2. And finally, when it is simplified to numerical terms, it got answer 4 by 7 a square, which works as a wonderful shortcut to find out the flowered region. Clear? Okay, this is a one type of analysis. And some of those guys who are having the awareness on the previous technique, in concept 1 we taught about the mensuration and some techniques of mensuration. There we taught something. Using that we can get the answer so simply. I'll tell you, let me tell you how it is. Okay, this is method 1 to analyze. Okay, we can analyze in method 1 like this. Now in method 2 how we'll do, let us see. Now in method 2, we are following method 2, what it is. See, I just want to remind you guys that in our first technique of circle and square combination, means concept 1, you may go to playlist of our videos. In our playlist, it would be number 1 video of the, number 1 in the sense, first video of the mensuration which we uploaded. Okay, so in playlist you can find it out that when a square is there and 2 semicircles are inserted into a square where side of the square is A, then these 2 gaps area would be how much? According to that technique, these 2 gaps area would be 3 by 14 A square. That was the first technique in the beginning of the sessions of mensuration I taught you. These 2 gaps areas, when these 2 are the semicircles, these 2 gaps area, sum of the gaps area, that would be means shade area. It would be how much? 3 by 14 A square. Did you remember this or not? Or otherwise, those guys who don't know about this technique, they may go to first concept and see. Next, let us see guys. Here, when we have this, one thing I'm asking you, that if you want to find out the white color flower, okay, then is it sufficient to subtract this pink colored region from square area? Once again I am telling you, this is square, means this entire area is represented by square. Now if you subtract this pink colored region from the square, then what is left? This flower only, no? Means this white colored portion only, na? So let us see now. According to this analysis, these two gaps are, see, once again I am telling you, just see here. Just see here, these two are two semicircles or not. This one and this one. Now these two gaps are, see, these two, this one and this one, these two gaps are looking like this or not. So here what can we say? Here A is a side, then this gap area would be how much? 3 by 14 a square. Similarly for these two gaps also, just see my pen point. So these two areas also, this also would be how much? 3 by 14 a square. So that means here these all pink colored areas would be how much? 2 times of 3 by 14 a square or not? If we subtract these all pink colored portions from the square area, can we get the flower or not? So that's it. Now if you want to find out, okay, now if you want to find out the shaded region, means white shade, okay, then white shade region over there, it's not a importance of color, in our diagram it is white, okay, white shade region area equal to, now tell me here, if we subtract this pink colored portions from total square, okay, here if we subtract this entire pink colored portions from entire square, this white colored region will be left over or not? That's it. So now here total square area would be a square because side is a. Now what we have to do here, these two gaps, means this and this gap area would be 3 by 14 a square. Like that another two gaps are there, that is another 3 by 14 a square. So now how can we find it? 2 times of 3 by 14 a square should be subtracted from that or not? That's it. 2 by 7. So that means that is a square minus 3 by 7 a square. So how much is that? 7a square minus 3a square, that would be how much? 4a square by 7. Is this somehow is better or not? This analysis is. But if you want to do this type of analysis, you must have a grip over all the concepts. Otherwise you better do in the first method. Okay, so here this is one of the concept in which we can get the answer of the shaded region as how much? 4 by 7 a square, or if you want to write that in terms of pi, that would be pi by 2 minus 1 times of a square. If you want to write down the answer in terms of pi, this answer would be pi by 2 minus 1 a square. And if you want to write down in the numerical terms, means lot of non-math students ask us for the shortcut methods. This is the best shortcut, that is 4 by 7 a square. Got it or not? Once again reminding you guys, here 4 by 7 a square is the area of what? This white colored flower. Okay, in first case we analyzed directly, and in second case we utilized the previous concept 1 technique here. That means here these two gaps area would be how much? 3 by 14 a square. Like that these two gaps are there, and here these two gaps are also there. So if you take here how many, means total pink colored shaded region representing, okay, 2 times of the 3 by 14 a square. If you subtract that pink color region from the total square, here flower region or white shade will be left over, which is our required part. We can get like this. These are the two methods we can the two methods, using them we can analyze the shaded region, white shaded region here in this diagram. It is not, color is not important here, white shade. Okay, flower shaped region is how much? 4 by 7 a square. Is that right or not? Here 4 by 7 a square. Which is that? Shaded region. Shaded region means white region. Okay, white region is how much? 4 by 7 a square. This is one of the shortcut for finding the area in this case. Now let us see that this 4 by 7 a square is a area of shaded region of any other diagram. Does it exist or not? Once again I am telling you, this 4 by 7 a square is a shaded region. Shaded region means here white colored region. Okay, flower shaped region. Let us see whether there exists some other problem also, or some other concept also, in which again shaded region would be 4 by 7 a square. If it is happening so, it will be very nice for you, because we can tackle with single shortcut two different types of patterns. Okay, let us see what happens. So we have drawn a square again, and let us introduce two sectors of 90 degrees each into that, for which the radius equal to the side of the square. Let us see. Let us look at this. Now this is one more case. Here we introduced two sectors of 90 degrees each and radius equal to side. Radius equal to side in the sense, for example, I'll say, see, side of this would be like this. I'll write here. See, this is side. If this is side, let me show how it is equal to radius. Here, if you take, let us see boys. Here, if you take this as a, see, if you consider this, is it a side or not? This is side. Okay, this is side, clear? So it's a side. Then you consider this as a radius and draw one sector. Is this a sector or not? It's a sector, clear? It's a sector drawn. And what is the angle made by the sector? Here this angle would be how much? 90 degrees or not? Because square angle is nothing but the angle of sector, clear? Now if you draw the same thing here, see, if you take here, from here also, if you take here also, this is a side. Side means this is A. See here, this is side which is equal to A. Now if you draw the sector here, is this a sector or not? This is also one more sector with radius equal to, it's a side. Is it side or not? Here side also is this, and radius also is same. That means here radius and side of the radius of each sector and side of the square are same. Means in this case radius and side are same. And what is the angle of each sector now? Here this would be, okay, here this would be how much? 90 degrees, and this would be how much? 90 degrees. Guys, if you carefully observe this, here also we got an overlapped region. How did we get? Just see. I just show you practically how it happened. Now just look at this. Just have a look at this. So see, if now this is a square, now as these two sectors are joining each other in a square, now this leaf shaped portion is nothing but overlapping region or not. Once again I am telling you, in any kind of figure, if another shapes are included or another shapes are drawn, then if we are getting overlaps one or other, what is the reason of overlap? Here reason of overlap is only just one thing. That is, here this square area is less than the sum of the areas of these two sectors. That means this sector area and this sector area, okay, are occupying more area than square. Once again I am telling you, because this is a key point to do this problem, I am explaining again and again. Okay, so here just see, this is a square occupying this total area. Clear? Now when this sector is drawn and here this sector is drawn, both the sectors are getting overlap over one another. And what is the reason behind overlap? Here just space inside the square is less than, means space inside the square is less than sum of the areas of two sectors. That's the reason behind one is overlapping another when we have drawn both of them inside, because of insufficient space. So that means here that overlapping region is nothing but this white colored part, shaded region. This would be your shaded region, right? This would be what? Your shaded region, and you need to find out. Here also tell me, my question is that whether to find out the difference of the areas from outer to inner figure is important, or okay, to subtract the area, less area from more area is important. The second one only, we have to subtract the less area figure from the more figure occupying more area. So here also what we have to do, according to conventional method, if you want to analyze the trick, analyze the shortcut, then only one thing is that here two quarter circles or two sectors of 90 degrees are occupying more area than square. That means difference from two 90 degree sectors to the square is representing shade, that means white color. Okay, so now let us find it out. Now what is a radius? Now tell me, here to find out the area of the square, what is required? Side or not? Side is there. Now to find out the area of the sector, what is required? Radius. We only said that experimentally, I have shown you also. Radius of the this sector is equal to side of the square or not? So definitely here R and A are equal. That's the first thing. So what we have to do? We have to find out the sum of the areas of two sectors, and from that we need to subtract area of the square. That's it. Let us do it. So conventional method we are doing now to get the shortcut. Now let us see what is the sum of the sector areas. How many sectors, boss? 2 or not? 2 sector areas. Okay, each sector area would be how much? Angle is 90 and radius equal to side. That means 90 by 360 times of pi. Your radius would be side itself. Okay, 90 by 360 means this will be how much? 4 times. Now I want to tell you, this is the area of one sector. How many such as sectors are existing? This is one sector and this would be another sector. So sum of the areas of two sectors would be 2 times of this. So like this 2. That means here how much is that area? Pi a square by 2. Again pi a square by 2 we got. Now what is area of square? Area of the square already we know, because it's a very simplest basic, that is a square, where a is the side. Now if you want to find out the difference between shade area, what I said, here semicircle's area is more than square area. Okay, so what we have to do, area of the sum of the, not semicircle, 2 sectors area, 2 sectors area is pi a square by 2. From that we need to subtract a square. So how to do it? Pi a square by 2 minus a square. Again if you take common a square, what will be the answer for you? Pi by 2 minus 1 into a square. So again we got the same answer for this, same as this or not? Okay, so here also we got the same answer. That means finally simplified answer for this also would be how much? 4 by 7 a square or not? So finally here also white colored region. See, white colored or black colored is not an important thing. That leaf portion is once again how much? 4 by 7 a square, where we got in flower shape also we are getting 4 by 7 a square as your answer. So it's a simple technique to find out the shaded region in 2 different cases or not. it's a one shortcut for two different problems, right? Did you get it or not? So like this we can analyze directly. That means we can get the shortcut for this case directly in conventional method. If you for this also there exists another method. What is that another method? That also based upon the concept number 1 technique. Okay, see here. Now let me remind you guys once again that what was the technique taught to you in the, like this also. Why I'm telling you this many methods, because okay, in any so some of the people will be connected to one technique and some will be connected to another technique. I don't want to leave anyone. Okay, so I want to be connected with every one of you guys, right? Let us see here. This is a simple one, but for this you need to remember the previous basics. Here I had given in the previous concept 1 video. If you go and see, if side of the square is A and one sector of 90 degrees angle and its radius equal to side of the square is drawn inside the square, then what is the area of this left region or shaded portion? This also I said 3 by 14 A square in the first case, if you remember. Otherwise, those guys who didn't watch this video, in our playlist you can go for the concept 1 video, you can get this. Okay, so here what is the area of this shade? This portion would be 3 by 14 A square or not? Let us just observe here. This is a sector of such kind or not? See, this is a sector like this. So is this a sector like this or not? Now tell me, this red colored portion is representing how much? 3 by 14 A square or not? 3 by 14 A square. Now again this red colored portion, because this is a sector, see like this it is occupying, that means this is also red colored portion only, no? This portion again is representing how much area? 3 by 14 A square. Okay, so now my target is to say only thing that you need to find out the white colored area. So now I tell you that here this square area is representing this whole. This total area is represented by as a square area. Now if you subtract this pink colored portion from total square area, what will be left, what will be remained over there? This white colored portion only now. So what we have to do, better we do, we subtract the remaining colored area, means remaining area or pink colored area from entire square area, then can we get the area of this white colored portion or not? It's a simple technique. So how can we get it? So shade area equal to, what? Area of the square minus pink color area. Pink color area would be how much? This is 3 by 14 and this is 3 by 14 A square. That means twice of 3 by 14 A square. Now if you subtract, what do you get? 2 sevens, that means 3 by 7 A square. Means on taking LCM 7 A square minus 3 A square, that would be 4 by 7 A square again. Is it simple or not? But one thing can be only simple when you remember all the concepts. If you don't know the concept, if you don't remember that, then better you go in a conventional method, as previously I said. Okay, leave about this conventional method or previous technique or what and all. Finally, you are a non-math student. You are expecting just a shortcut from me. Then what I have to say? Finally, I want to say that, just see. What is my final statement about these two figures? Whether, see, I am telling you a little bit humorously that here this is a flower, this is a leaf. Whether you draw a flower inside a square or a leaf inside a square, okay, in both the cases, if in this side also, here suppose side of the square is here also A and here also side of the square is A, in both the cases, okay, in both the cases what happens here, whether this leaf shape or this flower shape, both will occupy what area, what is the shortcut we obtained? That would be your 4 by 7 A square. In terms of pi, if you want to represent, that would be pi by 2 minus 1 A square. Clear? So that means here in this case or in this case, both are squares and here sides are A, then this leaf shape area means white color, or this flower shape area, both are representing what? 4 by 7 A square. That's it, final shortcut. Okay, so I think you would have understood this. That means here for two different cases, one combined answer we got or not. So that's the thing. Okay, here pi by 2 minus 1 by A square, pi by 2 minus 1 into A square, where answer is given in terms of pi, or 4 by 7 A square, where answer is finally numerically simplified. But of course for non-math, considering non-math students, it's a shortcut. 4 by 7 A square. For which? For these two cases. For this leaf shape or this flower shape. And one more thing guys, I want to tell you one more analysis also. Okay, so I want to tell you piecewise area collection also. See, I want just see here. Now just have a look at this. Now if where this area side is A, here also side is A, then we said that this flower or this white color shade, entirely white color shade is how much? 4 by 7 A square. Then this pink colored shade is how much? This pink colored shade, nothing. If you subtract this leaf from this entire square, then we get pink color shade or also not. So remaining area means here pink color region means remaining region would be how much? A square minus 4 by 7 A square. A square is entire square area, 4 by 7 A square is this area, then pink color region we got or not? That means remaining region. Here in this case pink. Okay, that would be how much? 3 by 7 A square. So this is a powerful shortcut to solve any one of the problems based on these two cases. And one more thing, here 4 by 7 A square is the area of how many this flower or not? Now tell me, if you consider these are the flower petals, all the flower petals are equal or not? When all the flower petals are equal, here 4 by 7 A square is distributed equally among all the flower petals or not? So here total 4 by 7 A square is the area of this 4 flower petals, right? Then if it is equally distributed among all, then each petal area would be what? 1 by 4th of that or not? So let us write this. Okay, each petal area would be how much? Here each petal area would be 1 by 4 times of 4 by 7. That means what? 1 by 7 A square. That means each petal carries how much? 1 by 7 A square, 1 by 7 A square and 1 by 7 A square. That's it. And here remaining area would be how much? 3 by 7 A square. 3 by 7 A square is divided into how many parts? Again 4 parts. That means each part will be occupied by how much? See here, 3 by 7 A square into 1 by 4 or not? That means what? 3 by 28 A square or not? So each gap will be occupied by 3 by 28 A square. And here also this is how much? 4 by 7 A square, and this is 3 by 14. This area is 3 by 14 and this area is 3 by 14. So this is the total analysis so that you can find out the area of each and every piece. So finally, before closing this session, I want to remind you guys that what is a shortcut finally? This leaf or this flower, 4 petals of flower, and this leaf area is 4 by 7 A square, a combined shortcut for 2 different cases. Clear? So hope you guys would have enjoyed this concepts and this combined shortcut of 2 different cases, and try to adopt this in your exercise while doing exercise also. And in our next video we are going to provide the exercises, 2 exercises for this diagram and for this diagram also based upon this. Okay, and don't forget to subscribe our channel to get the further updates. Thank you very much.